Hello, everyone.
Hello, ma'am. Good evening.
Good evening. Let's wait for 5 minutes and start the session. Okay.
Okay, ma'am.
Hello. Let's start the session. Hello.
Yes, ma'am.
Yeah. Okay. So in week 3, we are going to study about the expectation, variance, standard deviation, correlation, covariance, and lastly, Markov's inequality and Chebyshev's inequality. So first comes the expectation. Okay. So what is expectations? If we have to summarize the data, okay, if we have a large set of data, then we have to summarize it, right? So we have to summarize it in one number. Then we calculate the expectation. So how do we calculate the expectation? Expectation, it is denoted by E of X, which is equal to summation of T Fx T. Okay, so where this T is the variable, you can see, and Fxt is the function of that variable. Fine? Is it fine? Okay. So the expectation of X is also known as the mean of X, or you can say if you have to calculate the average value of X. Okay. And it has the same unit as X. Fine. Okay. So for example, if we have to calculate the expectation of a Bernoulli trial. Okay. Bernoulli trial with P as a parameter. So in Bernoulli trial, what are the probabilities?
P and 1 minus P.
Yeah, P and 1 minus P. Okay. So if the probability is 1 for P and 1 minus P is 0. Right. So if you have to calculate the expectation, it will be the value that is 1 into probability is P. Right. Plus 0 multiply its probability is 1 minus P. So it will be equal to T. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yeah. So if we have to now other example, if I have to calculate the expectation of if I'm throwing a die, okay, if I'm rolling a die, then what is the expectation, right? So what are the chances? The chances are 1, 2, 3, 4, 5, and 6, right? And the probabilities are for 1, the probability is
1 by 6.
1 by 6. Similarly, for all of them, the probability will be 1 by 6, correct? So if I have to calculate the expectation, that is the average value, it will be
1 by 6.
1.
1 into 1 by 6 plus 2 into 1 by 6.
Yeah, 1 by 6 into 1 plus 2 into 1 by 6 plus 3 into 1 by 6. Similarly, it goes to 6 into 1 by 6. Then this total will be equal to 3.5. So the probability is the expectation is 3.5. Right? So this is how you calculate the expectation. Okay. So there are many, you can say, like there are many distributions. Okay. So for like geometric distribution, for Poisson distribution, can say. For Bernoulli, it was, the expectation was P,
NP.
right?
Oh, P.
Bernoulli.
Yeah, P.
Yeah. For binomial, it will be NP. Okay. For geometric, it will be 1 by P. Right? And for Poisson, it will be
Lambda.
lambda. Okay. So these are the expectations. Okay. Now from the graph, if we have to calculate, like if you see the graph here, if you can see the graph, it's the Bernoulli distribution and the P value is 0.3. Okay. So if we draw a graph here, the expected value will be the, you can say the highest point, you can see, right? This bar is having the highest point, right? Compared to this. Correct? So this will be the expected value, which is 0.3. Okay. Now, binomial is like we have binomial distribution. It is given N and P. Correct. So if we draw a graph here, okay, so we see that expectation is 6. That is, expectation of binomial is NP, right? N is 20 into 0.3, which is 6. So the expected value is 6, which if you can see, it is the higher point, the highest point you can see. So the expectation value or the average value is the highest point in the graph. Fine.
Yes, ma'am.
Is it clear? Okay. Now let's come. Now there are some properties of expectation. Okay. So the first property is the first property is the expectation of any constant value is always C. Okay. Second, like if we having the x, it is negative value. It is taking negative value, right? Then the expectation is greater than 0. No, sorry.
Greater than or equal to.
No. If the probability of x greater than 0 is 1, then the expectation is greater than 0. That is the x value is always taking non-negative values. It is not taking any negative values. Okay. So if it is taking only non-negative values, then the expectation will also be non-negative. Fine. Now there comes a
Why?
theorem.
Sorry. Why is that so?
Why is that so?
Probability is always greater than 0.
The probability that the x will that x is taking always positive value is 1. Okay, so the expectation will also be positive, right?
Okay.
Yeah, like in the above example, if we have seen throwing a dice, all the values of x are positive, right? And the probabilities is positive.
Okay, what you're saying is x doesn't have a negative value at all.
Yeah, if x is not having negative values.
When x is not having.
Ma'am, expectation value is
Expected negative value also.
Sorry?
When x is non-negative, then only expectation is non-negative.
Yeah, greater than 0.
Ma'am, what I was saying is, ma'am, this expectation value is an average, ma'am. So average is always positive only, ma'am.
Positive only. Yeah. It can't be negative.
Ma'am, I have a doubt in that. There are few questions like, for example, given a probability of, if I toss a coin and I am getting a probability of head as half, and let's say I toss a coin and when the head comes, I get I get 5 rupees for getting head, and I get minus 10 rupees for tails. In that case, my average would always can be negative, na?
She put a condition x doesn't become negative in this.
So, ma'am, then the statement becomes wrong, na? Ki average
This is not applicable in that case because x is negative in your case.
Yeah. Here I'm talking about the x is only taking positive values. That's it. It's not taking any negative values. Fine?
Yes, ma'am.
Okay. So, yeah. And the third theorem, it says that if we are having, suppose if we are having x1, x2, and xn, we are having a joint, they are having a joint PMF as fx1. This is the joint PMF of x1, x2, and xn random variables. Okay. Then let y be a function of x1, comma, x2, xn. Okay. With range as ty and PMF as fy. So if we have to calculate the expectation of y, that is, we have to calculate the expectation of function of x1, comma, x2, xn. Okay, then it will be equal to summation of this function, that is x1, xn, multiplied by the joint PMF of x1 to x. Got it? Everybody got it? This theorem.
Yeah.
Yes.
Yes.
Right? Means like if we have to calculate the expectation of y, which is a function of x, okay, then we can calculate, like we don't have to calculate the joint PMF. We can simply calculate by that function only. Okay, let's for example, like we can say if the values that x is taking -2, -1, 0, 1, and 2. Okay, and the probability is for -1, -2 is 1/5, -1 is 1/5, for 0 is 1/5. Similarly for the other twos. Okay. Now, if we have to calculate, that is, the y is x square, right? So if you have to calculate the expectation of y, then it will be equal to, that is the function, right? The function is x square. So x square is, that is -2 square into the probability is 1/5, correct? Plus that is -1 square into probability, that is 1/5. Similarly, we can calculate the other values. Square into 1/5 plus 2 square into 1/5. Is it clear? Here we are not calculating the joint PMF. That is, we are not calculating the x square first, right? So if it's x square, then the values the x square will take is 0, 1, 4, right?
Yes.
Yeah. So the probability of 0 will be 1/5 only. For 1, it will be
Yes.
2/5, and for 4,
2/5.
it will be 2/5,
3/5.
right? 2/5.
2 times repeating the values.
Okay. So here we are not like we are not putting the joint PMF. We are just putting the values of the function of x, the x. That's it, right? So it is not necessary that you have to calculate the joint PMF. Then you can, like, you have to calculate the expectation. Just putting the values of the function of x, you can calculate the expectation.
Ma'am, in this case, if g of x is something like 3x, how will we find expectation of y? If the function is instead of x square, if it is something like 3x. So do we multiply this to,
yeah, there is one more property, if you can, like, if there is one more property, expectation of c into x, that is constant is multiplied by some variable, then it will be equal to c into expectation of x.
Oh yeah, so in that case we can do this. So what if it is like we have seen cases like xy, but
xy, like there are two random variables, right? X and y.
Yeah. Can we use this theorem there as well?
Yeah, I will get to that point. Okay. So is this clear? This theorem, third theorem?
Yes. Example is clear. That definition is fine. Yeah.
Definition is confusing.
Yeah, for me it is.
Okay. What's the confusion?
Yeah, I was trying to actually map it to other functions like 3x. So you gave an example of a different property altogether. Can we use the same function there? Is what same theorem there is what I was thinking.
3x, right?
So that is also a different function, right?
Yeah, it's a different function. So like you can do it, right? Like 3 into -2 into 1/5 plus 3 into -1. So it will be only 3 into expectation of x, right? See.
Okay, so every possible value we change it into that function and then multiply.
This will be the function, right? Multiply with by probability plus 3 into -1. This is one function into 1/5. Similarly for the other cases. Okay. So here, if you can see here, the 3 is common. So we are just taking out the common and writing the whole part again. That's it.
Right.
and this is simply the expectation of x.
Correct.
Get it?
Yeah.
Yeah, that's it. Now it's clear?
Yes, yes, ma'am.
Yeah. Everybody?
Ma'am, if you draw the graph of this y equals to x squared, how are you going to plot this expectation values on this? Can you explain a little bit?
Sorry, what?
Ma'am, can you show us the last step?
Which last step?
The fourth one, the calculation. Yeah, this one. Yes, ma'am. Ma'am, got it. You can proceed.
Okay. So the third property is clear to everyone?
Yeah.
Can we proceed?
Ma'am, I was telling that initially you started and you displayed some graph of this expectation that you showed some, it will look like this. In this case, when we have a function like this y equals to 4x squared, which is a parabola, how are you going to draw this expectation values on such things?
Of x square. Right now, I'm not sure. But on Tuesday, I'll clear this down. Right?
Okay.
Yeah. Okay. Okay. So, three properties are done. Now, the fourth property is the linearity of expected value. Okay. It says that the expectation of constant multiplied by some variable, it will be constant multiplied by the expectation. Okay. This is the fourth property. And the fifth property is the expectation. If you have been given two random variables, that is x and y. So the expectation of x plus y will be expectation of x plus expectation of y. Got it? It is not necessary that it should be independent or dependent. It's just that we have been given two random variables, x and y. And if we have to find the value of, please mute yourself. Yeah. So, yeah, if like it is given that only like we have been given two random variables, x and y, and we have to calculate this expectation of sum of these two random variables, then it will be equal to the expectation of x plus expectation of y. Got it?
Yes.
Yeah. So now other, like if it's given ax plus by, then it will be equal to
A into expectation of x plus b into expectation of y.
Yeah, correct.
Ma'am, can you show us an example of, for this theorem, the number 5?
Theorem 5. Okay.
Yeah.
So okay, let's take an example like x comma y are taking values. Right? These are the coordinates. Okay. 1, 0. 0 can be 1. 1, 1. Minus 1. 1, 1. Okay. These are the values that x and y are taking. Right? So now, like I want to, the function, there is one other function of x and y, which is x square plus xy plus y square. Okay. So if we have to calculate the expectation of this value, right, that is x square plus xy plus y square. Okay. So just suppose that this is one variable, this is one variable, and this is one variable. Here we had two variables, the sum of two variables. If we have sum of three variables, then it will be equal to expectation of x square plus expectation of xy plus expectation of y square. Yeah. Till here it's okay.
Yeah, ma'am.
Yes, ma'am.
Yeah. Okay. Now the value that we have to calculate the expectation of x square. Okay. So the x is taking values 0, 1, and minus 1, right? Or yeah. So the probabilities will be, so 0 is taking
2 by 6.
2 by 6. 1, 3 by 6, and minus 1, 1 by 6. Okay. Similarly, the y is taking values 0, 1, minus 1. Fine. So the probabilities will be 0 will be 2 by 6, or 1 will be.
Ma'am, how are you calculating this?
3 by 6.
2 by 6, 3 by 6.
Okay, fine. See, this is the data. So here's, this is representing the first point is representing the x, and the second is representing the y. Yeah. Similarly for the other, this is representing the x and this is representing the y. So if you see in this data, that what are the values of x? Just give me the values of x.
0, 1, and minus 1.
0 and 1 and minus 1, right?
Yes.
And how many points are there? 1, 2, 3, 4, 5, 6, right? So how many times x is taking from the 6, out of 6, how many times the value 0 is occurring?
Twice.
Twice, right? So 2 by 6. Similarly, how many times 1 is occurring?
Thrice.
Twice. That is this. And minus 1?
Only once.
Once, right? So this is how I calculate the.
Okay, ma'am. Clear.
Clear?
Yes.
Yeah. So you have to calculate the values of x square. How will we calculate the value of x square? The x variable is taking this values. So tell me.
0 square into 2 by 6 plus
1
square into 3 by 6 plus minus 1 whole square into 1 by 6.
So this will be 3 by 6 plus 1 by 6, which is 4 by 6. This is clear?
Yes, ma'am.
Yeah. Similarly, we can calculate all the values, that is x square, expectation of xy, and y square. Yeah. So the values, see, the values of expectation of x square is 4 by 6. Expectation of xy is minus 1 by x, and expectation of y square is 6. So if we put these values, that is 4 by 6 minus 1 by 6 plus 4 by 6. So we will get 7 by 6 as the expectation. Got it?
How did you calculate
Yes.
that expectation of xy so fast? Did you have it written or?
Yeah, I
you-
just calculated on my own.
Okay.
Ma'am, can you show the xy part? XY part, how you're calculating?
The xy part.
Yeah. How you're getting minus 1 by 6 for xy.
Just if you see,
I think we have to list down the possible.
you can write it as expectation of x and expectation of y. Fine. If you can if you can like the expectation of xy can be written as expectation of x and expectation of y. So if you calculate the expectation of x, then multiply it by the expectation of y, you will get the value as the value of expectation of x and y.
But
right?
this is possible only when it's independent, right?
Yeah, this is an independent case.
Okay.
Right?
Okay. Yeah.
So yeah. So this is how you
Same
can
be done for x square as well.
sorry, what?
Same can be done for x square as well. It can be written as expectation of x into expectation of x.
Yeah.
No, that would be clearly independent, clearly dependent, I think.
Yeah, it's x square, right? You are just the x and y are independent. The two variables are independent. The x is not dependent on y. That's the thing.
Okay.
And how would we find the
Ma'am, probability for which variable given, x or y?
Okay, just give it just a second. Okay. I said it wrong. Okay, it's not independent because see, x and y are the points, right? 0, 0, 1, 0, 0, 1, right? These are the points, coordinates, right?
Yes.
Yeah, so it can't be independent. I'm very sorry about that. It's not independent. How? Because the values of y is dependent on x, right? So if we are having the coordinates, right, they are dependent. If we are having one value of x, we can calculate the other value of y. So it's dependent, right? If we are having some function and if we have to calculate the coordinates of y, like if we are having some linear function x plus 3 is equals to y. So like if you have to find the coordinates, how we used to calculate the coordinates, like putting the value of x and calculating the value of y. Correct? So it is dependent. The coordinates, they are dependent. They are not independent. Okay. So how did we so this will not apply here. Okay. So we calculated expectation of xy as the first, what was the data? Like it was 0, 0, the first multiplied by the what will be the probability 1/6, right? 1 times it is appearing. Correct?
Yes.
Is it clear? Yeah. Similarly, the next point was 1, 0 multiplied by its probability. Similarly, 0, 1 into 1/6 plus 1, 1 multiplied by 1/6 plus minus 1, multiplied by 1/6 plus 1, minus 1 multiplied by 1/6. So here we are multiplying the values of x and y, right? So we will multiply these values, these coordinates, the values of x and y. So it will be 0 multiplied by 0.
0.
0 multiplied by 1/6. Similarly, 1 into 0 is 0.
0.
0 into 1/6 plus 1 into 1/6 minus 1 into 1 minus 1 into 1/6 plus minus 1 into 1/6. This part is clear?
Yes.
Last one is minus 1?
Yes.
Yeah, it will be minus 1. 1 into minus 1.
Answer minus 1/6.
Right? So this will be 0, 0, 0. This will be 1 by 6. This will be minus 1 by 6. And this will be minus 1 by 6. This will get cancelled. So our if the expectation is minus 1 by 6.
Ma'am, can you explain x square and y square once again, please?
Okay. So this part is clear?
Yes.
No, ma'am. How
Yeah.
did we? Yeah.
What is the doubt?
I understood the first part. How we wrote, that's a definition. How did we simplify this? How was that 0 into 1 by 6 plus?
See, we are calculating we are multiplying the values of x and y. This is clear? This part. We are
Yes.
calculating the multiplication of x and y values. Fine. So x is taking z. So here the coordinate, the x value is taking 0 and the y is taking 0. So if we multiply, we will get 0. Correct?
Oh, okay. So it's xy. Okay, okay.
Yeah, this is xy. This is also xy. That is, the points are getting multiplied. Now it's clear? 1 into
Yes.
0, 0
Yes,
into
yeah.
1, 1 into 1, like that. Fine?
Yes, ma'am.
Okay. So this part is clear? Everybody?
Yes, ma'am.
Okay. So some x square, right? Who had a doubt in x square?
Ma'am, me.
Yeah. What is your doubt?
Ma'am, for like the way how we calculated xy, same can be done for x square as well. Like those points will be 0, 0 and 1, 1. Is it?
How?
If x
Like,
and y are
that's the
values,
thing. Yeah, we are just only taking the values of x only, right? And we are just squaring it up.
Ma'am, write sample space, ma'am. There we will understand, I think.
Sorry, what?
Sample space of x and y.
Yeah. Like here we are taking only the values of x. We are not taking the values of y. So we are just squaring the values of x, that is 0 square, 1 square, and minus. See, in the sample, in the data, the coordinates, the x values, what are the x values? 0, 1, 0, 1, minus 1, and 1. That is, the x is taking 0 value, like here, 0, 1, and minus 1. These are the values that x is taking, right?
okay, got it.
Yeah. So we are just squaring the values of x. We are not taking the coordinates. We are not taking the y variable. Here we are taking only the x square. That's it. The x values.
Okay, okay.
Yeah. Is this example clear? By everyone?
Ma'am, can you show the problem? Question.
This is,
Where is the question? Ma'am?
yeah, this one. See, if x and y are taking values.
Oh,
like
that itself. Okay. The x and y are okay. Distributed as.
Fine.
This is the PMF, right?
Yeah, this is the values that x and y are taking. That's it.
Okay.
Yeah. Can I proceed? Can I proceed further?
Yes.
Yes, ma'am.
Okay. Okay. So like this property only if we apply in binomial, right? See, in Bernoulli, the expectation was P, right? What is binomial? Like if x is following Bernoulli, then what is binomial? That is x1, comma x2 till xn, right? It is following binomial distribution, correct? With n and p as the parameter. So what will be the expectation?
NP.
How did we calculate it? See, in Bernoulli, the expectation of x was p. So in binomial, it will be sum of all the trials, that is x1 plus x2 plus till xn, right?
Yes.
Is it? Yeah. So we will follow the property that is x1 plus so the expectation will be expectation of x1 plus expectation of x2 till expectation of xn, and all these like x1 x2 they are following Bernoulli with expectation p, right? So the expectation of x1 is
P.
p plus expectation of x2 is p till this. So how many values are there? There are n values, that is np. This is how we calculate the expectation of binomial with this property. Fine?
Yes, ma'am.
Okay. Now comes the zero mean random variable. What is zero mean random variable? Okay. Zero mean random variable is that in which, like, if y is a random variable, then x minus expectation of x is a zero mean random variable. Like if a random variable x is subtracted by its expectation of, like if we calculate the expectation of y, then the expectation is 0. Here y is denoted as x minus expectation of x. See, if y is a random variable, like y is denoted as x minus expectation of x, and if we are going to calculate the expectation of y, then it should be equal to 0. See, the value, the expectation of x minus expectation of x only, right? So this will be 0 only. You getting it? Like zero mean random
Yes,
variable
ma'am.
says that if there is one random variable, okay, with expectation of x as 0, so this is known as zero mean random variable. That's it. If the expectation of any random variable is 0, that means it's a zero mean random variable, right? So if we are if we are finding out the expectation of x minus expectation of x, right? If we are just subtracting the random variable with the expectation, then the value is 0. Getting my point?
Ma'am, won't
Yes.
that be expectation of x when you break the second last line?
But that is a constant, no? Expectation of a constant is always.
Yeah, this is a constant value. So expectation of a constant value is
The
C
constant.
only. Yeah, that is expectation of x.
Okay.
So if we are subtracting expectation of x from the expectation, it will be 0 only, right?
Okay.
So till here, anybody having any doubt in any topic?
But the given data is expectation of x equal to 0. Expectation of 0 is 0. So that's what you have to write.
Sorry.
What is the given data? X and the expectation of x equal to 0. Is it?
No. It's no. Zero mean random will says that if there is one random variable x with expectation of x as 0, if that random variable's expectation is 0, then it will be said that it is a zero mean random variable. That's it.
Okay. Therefore, here if you take e out inside the bracket, expectation of x minus expectation of x must come, no?
Yeah. So see, if I break down this, it will be expectation of x minus expectation of
expectation of
expectation.
right? Yes, yeah.
Yeah, it will be this, and this is a constant term. Let us denote it as c.
Okay.
So expectation of c is
c.
So this will be equal to expectation of x minus expectation of x only.
Okay. C minus c is 0.
Yeah. So like if this is c and this is It get cancelled, it will be 0, right?
Okay.
Ma'am, why we are breaking this expectation of x minus expectation of x as expectation of x minus expectation of x? I'm not getting this and I'm unable to digest this one. Because whenever we are given a set of data, say suppose there are x1 to x100, we find its mean, that is expectation of x. So first we will find the difference between every point A of x with that mean. Some will be positive, some will be negative, and when we add them, it is always equal to 0. And why we have to break this one to explain this or to prove this?
See.
Because it is take
listen,
any data set, even if it is
I got it. See, zero mean random variable states that if you are given a random variable x, okay, with expectation of that random variable as 0, we are getting that expectation, the average value is 0, then this variable is known as a zero mean random variable. Fine.
Ma'am, expectation of any variable, whether it is random or non-random, when we find the expectation of any given series, it will always be 0.
Ma'am, can you take
the difference between, I mean, the difference what we are doing here?
The expectation can't always be 0.
No, I have not expectation. The difference between that particular series of x and the expected value of that particular series of x. So here you are telling that if any single random variable is given with its expectation is equal to 0, its x is not a series. X
it's a variable.
Is a single variable. Okay.
Yeah.
Ma'am, which is a zero mean random variable, y or x here? You are defining the definition for...
I'm just defining y as a random variable here. And y is a function, like I'm denoting y as x minus expectation of x.
Okay, y is called a zero mean random variable.
Yeah, so this here, like it's like obvious. If I'm taking the expectation of this, the value will be 0 only, right? If I'm subtracting any variable by its expected value and taking that expectation, it will be 0 only, correct?
Yeah.
Yeah, that's the thing. See, the expectation of x is some value that is, let's say a, right? So if I take this value here, so it will be expectation of x minus a equals to 0. This can be written as expectation of x minus a equals to 0.
Ma'am, but it's not necessary that x should take that value a in first place, ma'am.
No, I'm just taking a as a variable, like any value. Take an example, that's it. I'm not taking any value, particular value. It's just an example, like the expectation is a. Let's consider it as a, right? So if
that means we have calculated the mean of that x as a.
Yeah. So if I subtract it by that random variable and take that expectation, it will be 0 only, correct?
Yes.
Yeah, that's the thing. So I just subtracted that variable by the expected value. And if we take that expectation, we will get 0 only. That's it.
Understood, ma'am.
Yeah. Everybody got it?
No, ma'am. Getting confused, ma'am.
Just remember that the 0 random variable is that random variable whose the expectation of that variable is 0. That's it.
Okay, ma'am.
Yeah, that's the thing. Here I just took an example of y as this random variable does, and I just calculated the expectation, and I got 0 as the value. So expect that is the y is a 0 mean random variable. That's it. I just took an example of y as this. It is a function of x, okay, and I just calculated the expectation, and I got the value 0. So y is a...
May I add something?
Yeah.
Zero mean random variable.
Yeah, that's it. Yeah.
Can I
Because
add something to
y
clarify?
screen is 0, that's why we call it as y is a 0 mean random variable. If you take a expectation for x minus expectation of x, it becomes 0. If anytime if you expectation of x is, that value only will come. Expectation of x value only will come. So that average of average is only one value. Is it correct?
Somebody wanted to add something.
I will give a simple explanation why we do this. If we take a x to be 3 numbers, 2024, 2030, 2044, if we got to find a variance and various other complex calculations on that, it is going to be difficult manually. If we find the mean of it and subtract and define a new variable y, it will be zero centered. It's easier to calculate, and then we can go back to the original x whichever way. So you're defining a new variable y as x minus expected value of x makes it convenient for calculations. That was the purpose of introducing a zero mean value variable.
Yeah, as a standard, you can say standard.
That's a normal practice. One of the practice, we are basically shifting x to y. We are defining a new variable y.
Yeah, we are just translating it by the expected value.
The reason why we are defining y is it is more convenient to do work on y and get back to the results to the x domain later. As an example, you can simply take 3 numbers, 2024, 2040, 2070 or something like that. If you go to do the calculation of a variance, you will find it a very large number to handle. It is complex. If you shift it to zero mean, it's easier. Smaller numbers. There are some convenient properties based for the zero mean. Using that, we can find all those properties, then shift back to x. It's one technique, that's all.
Is it clear now?
Yes, ma'am.
Yes, ma'am.
Let's go to other section, which is variance. Okay. So in expectation, we calculated the average value. Okay. So why we calculate the variance? We calculate the variance to know the spread of that data, right? So for example, like x is taking value, x is taking only one value as 10. Okay. Y is taking only value 9, 11, and z is taking value 0, 20. Okay, these are the values. So if I calculate the expected value of every one of x, y, and z, we will get as 10 only. Okay, so all the values of expectation are same for all the variables. Okay, but this like if we look into the data, the data of x is different, the data of y is different, and data of z is different. So we are not able to conclude about the data from the expected value, right? So for that, we calculate the variance of x, variance of y, and variance of z, right? To see about to visualize about the data, how much spread is there in that data. So if we look, that 10 is just 1 point, right? From 9 to 11, there is not that much of spread. Like 2 values different is there. From 0 to 20, it's a spread, right? 0 is here and 20 is here. 9 and 11, that's it. Then 10. So if we look the spread, if we have to visualize the spread, we calculate the variance. Fine? Is it clear why we calculate the variance?
Yes, ma'am.
Yeah. So the formula of variance of x is expectation of x minus expectation of x whole square. This is the formula of variance. And if we have calculate the standard deviation of x, it will be the square root of variance of x. Is this formula clear?
Yes, ma'am.
Yeah. So if the values of variance of x, like the variance of x is more, that means the spread is more, right? So like for example, like this example, x is taking 10 value, y is taking 9 and z. So if we have to calculate the variance of x, right? So variance of x will be, that is expectation of, what is x? That is 10 minus expectation of x is 10 whole square, right? This will be 0. This is clear how I calculated the variance for the
Yes.
x variable, right? For the y variable, it will be expectation of, that is expectation of these values. So it will be equal to that is 9 minus 10 whole square with probability. Like if the probability they are taking 1 by 2 and 1 by 2. So it will be 1 by 2 plus 11 minus expected value whole square multiplied by 1 by 2. Is this step clear? Is this step clear?
Yes, ma'am.
No, ma'am.
No. Okay. See, the variance of x is calculated by expectation of x minus expectation of x ka whole square, right? So here the values of y, the y are taking two values, 9 and 11, right? So if you have to calculate the values of x, like if you have to calculate the expectation, simply it was 9 into 1 by 2 plus 11 into 1 by 2. This is how we calculated the expectation, right?
Yes.
Now we have to calculate the expectation of x minus this. So it will be, what is x here?
No, right, y. They'll get confused. Y minus the expected value of y.
Sorry. Okay. So the value of y is what is the value of y?
9 and 11.
9 and 11, right? So for the first 9 minus, what is the expectation of y? Here the expectation of y is 10. So 9 minus 10 whole square multiplied by the probability, that is 1 by 2. Plus the other value of y, that is 11 minus expectation, that is 10 whole square multiplied by 1 by 2. This is how I calculated the expectation. Is this clear now?
Yes.
Sure?
Yes.
Okay. So if I calculate this value, I will get 1 as the answer. Similarly, if I calculate the variance of z, it will be equal to 0 minus 10 whole square multiplied by 1 by 2 plus 20 minus 10 whole square multiplied by 1 by 2. Okay. So if I solve this, I will get 100 as the answer. So if you see, the expectation of all the random variables will same, but the variance is different. For x is 0, for y is 1, and for z is 100, right? So for z, the variance is 100. That means the spread is more compared to y. So for y is it is 1. So the spread is okay, fine. And for the x, it is 0. That is, there is no spread. Got it?
Yes, ma'am.
Yeah. So this is why, that is why we are calculating the variance, to know the spread of the data. Because from the expectation, we are not able to know, or we are not able to visualize about the things about the data. That's it. Fine.
This number has no mathematical significance in quantifying the spread, is it?
So what?
I mean, the number From that, we cannot actually make out how much is the spread. We can only say relatively. Is that what you're coming to?
Standard deviation will give you that. Standard deviation will give you more clarity because you take a square root, it becomes meaningful. From the variance, you take the square root of it, it becomes a standard deviation. That will be related to the mean so that you know how many sigmas you are away. That will come later.
Yeah.
Fine. So, like, if you have to calculate like x is taking values 1, 2, 5, 6. So how we will calculate the variance of x? What is the formula of variance?
Expectation of x minus expectation of x, the whole square.
Yeah. So let's like the value, the x is taking value 1 minus the expectation of, like in earlier we calculated that expectation of x is 3 point, right? So it will be 1 minus 3.5 whole square multiplied by the probability, that is 1 by 2. Right. Similarly, we can calculate the other values.
Is it 1 by 2?
1 by 6. 1 by 6.
Sorry, 1 by 6. Okay. Plus 3 minus 3.5 whole square multiplied by 1 by 6. So here we can put all the values to 6 minus 3.5 whole square multiplied by 1 by 6. So is it clear how to calculate the variance?
Yes, ma'am.
Okay. Now we have some of the properties of variance. Okay. The first property states that variance of a into x, that is, if we are multiplying any variable with some constant, it will be a squared into variance of x. The constant will be squared, and we can it is multiplied by the variance of x. Fine. Second, the standard deviation of a into x will be mod of a into standard deviation of x. Is it clear? Because like the standard deviation of x is the square root of variance of x, right? So the standard deviation of if you are putting if you are calculating the standard deviation of a of x, it will be the square root of a square into v of x, correct? And square root of a square is mod of a, we are just taking the positive value, and square root of vx is standard deviation of x. That's it. Got it? Is it clear?
Yes, ma'am.
Yeah. Then the third property is variance of x plus a will be variance of x only. Okay, we will not take the value of a. If we are multiplying any constant, then we are squaring it. If we are adding any quantity, the variance remains the same. That's it. Okay. And the fourth property, the standard deviation of x plus a will also be equal to the standard deviation of x. Are all the properties, the fourth property, clear?
Yes, ma'am.
Okay. Now we calculate, there is another formula of variance of x. It is expectation of x square minus expectation of x whole square. Yeah. So expectation of x square can be calculated as summation of it will be t square probability of, sorry, x equals to t, correct? And expectation of X can be written as summation of t probability of x equals to t whole square. Correct?
Yes, ma'am.
Ma'am, in LHS, it will also be whole square.
Huh. Right. So here the x square, it is denoted as the this is denoted as the second moment, and expectation of x is called as the first moment, and variance of x is called as the second central. These are some of the terms that they do. Just have to just remember that. That's it. X square is denoted as the second moment. Expectation of x is called as the first moment, and variance of x is known as the second central moment. Fine.
Ma'am, second central.
Central moment. Yeah. Fine. Can I proceed further?
Yes,
Yes,
ma'am.
ma'am.
Yeah. Now comes the there is one property. See, in expectation, if we are given two variables x and y, and we are calculating the sum, we are calculating the expectation of sum of two variables. It was
Expectation of x plus expectation of y.
yeah. In this, it was not necessary that these two variables should be independent or dependent, right? So, but if it is given that x and y are independent, okay, then expectation of x into y will be equal to expectation of x into expectation of y. This is the first case, if they are independent. And the second case, the variance of x plus y will be equal to variance of x plus variance of y. These are the two conditions if x and y are independent.
Oh, so if it is not independent, we cannot sum
We
the
cannot,
variables.
no,
Okay.
we can't. Only if they are independent, then we can calculate the variance of sum of these two variables. Got it clear? Okay. Now there are some distributions. Okay. For Bernoulli distribution, the variance is p into 1 minus p. Right? How we calculated it? See,
NP 1 minus p.
I'm talking about Bernoulli.
Not binomial.
Bernoulli it is. See, in Bernoulli, the x is taking value 0, comma 1. Okay. And the probability is p, and this is 1 minus p. So if you have to calculate the variance of x, it is expectation of x square minus expectation of x whole square. Correct? So
Yes,
expectation of x square will be
1 minus p. 1 minus p.
expectation of x square.
Yeah, 1 minus p.
1 square into 1 minus p, right?
1. Yeah, 1 square into 1 minus p. It will be equal to 1 minus p. And expectation of x will be
P.
P.
No, I think 1 minus p.
It's supposed to be p. I don't know why it is 1 minus p.
And the problem is
just a second. No. See, the probability is
You have taken probability different.
0 to
different.
b.
Yeah, correct. So 0 is taking probability 1 minus p, and 1 is taking the probability p. Fine. Then this will be equal to
P square.
this will be p, and this will be okay. Yeah. So if I put this value in this, so it will be equal to expectation of x square is p minus expectation of x whole square will be p square So taking P as a common, it will be P into 1 minus P, or you can rewrite it as P into 2. Fine?
And would you please explain how did you get expectation of x square?
Simply as like expectation of x square will be 0 square multiplied by 1 minus P plus 1 square multiplied by its probability, that is P.
Okay, okay, clear.
Yeah.
Mm.
Yeah. So variance of Bernoulli is clear?
Yes, ma'am.
So if I have to calculate the variance of binomial, so it will be equal to variance of x1 plus x2 till xn, and all are independent. Then it will be equal to variance of x1 plus variance of x2 till xn, right? For one variable, the variance was pq, right? So it will be pq plus pq till pq. So there are n terms, it will be np, or you can write it as np1 minus. Is it clear?
Yes, ma'am.
Yes. Okay. Now comes the standardized random variable. What is a standardized random variable? A random variable x is a standard if the expectation of x is 0 and variance of x is 1. Okay. A random variable x is said to be standardized if the expectation is 0 and variance is 1. Is it clear?
Ma'am, can you please repeat once, ma'am?
See, if a random variable that x is a random variable, okay, we have to say that it is standardized when expectation is 0 and variance is 1. Then x is said to be standardized. Okay, and if I have to standardize a random variable, how will I, like, if y is a variable and I have to standardize it, then I will like if I have to convert this variable into standardized random variable, then I will calculate it by x minus expectation of x divided by variance of x. Like if x is a random variable, if I subtract it by the expectation and divide it by the variance, then I will get a standardized random variable.
You divide by sigma, not variance.
Sorry. Yeah.
Square root. Ma'am, basically what we are doing is we are shifting from x to y, so
Yeah,
that
we are
it
just
becomes a standard.
Yeah, just we are shifting the x variable, we are converting into a standardized random variable. It will be easy for the calculation. That's why we standardize random variable. Is it clear?
Yes, ma'am.
Yeah. So till now, till the variance and standardize, everything is clear? Is it clear, everyone?
Yes, ma'am.
Yeah. Okay. Now comes the covariance. Okay. So what is covariance? If we want to summarize any relationship between two random variables, if x and y are two random variables, okay, and if I have to summarize the relationship, what is the relationship between the two random variables, then I calculate the covariance. Like if I have to know if the values of x is increasing, then how it is affecting the values of y, right? So if I have to like if I have to know or summarize the relationship between these two, then I calculate the covariance. Okay, and the formula of covariance is expectation of x minus expectation of y multiplied by expectation of y y minus expectation of y. Clear? Is it clear why we calculate the covariance and the formula?
Yes, ma'am.
Yeah. See, so the first thing, if the covariance is positive, okay, that means if x is increasing, then y is also increasing. Secondly, if covariance is negative, that means if x is increasing, then y is decreasing. That it's going opposite. Okay. And thirdly, if it's 0, right? So that means it is uncorrelated. Is this clear? Everyone?
And can you give us an example? Like, what do you mean by when x is increasing or y is decreasing?
Just like for example, x is taking the height, right? It is the height of a person, okay, and y is the weight. So if a person height is increasing, then the weight is also increasing, right? If a person is having a he's increasing his height, then the weight is also gets increased, right? For the normal general cases.
Yeah.
So the covariance is positive, right? That means that if x is increasing, that means the y is also increasing. If I take another example here, like x is, you can say, scores the runs by a cricket, like a person, and y is the wicket. So if the x is increasing, that is the runs, they are scoring the runs, then the wicket will be decreasing, right? The number of wickets will get decreased. If they're scoring number of runs, if one person is scoring a huge number of runs, then the wicket will be decreased, right? So it's negative.
Okay, ma'am, in terms of random variable, like how will I define it? Let's say I have a random variable 1 to 10. How will I define that if this is increasing or this is decreasing?
X is taking value 1 to 10.
Yeah.
And y?
And y is taking, let's say, 10 to 15.
Yeah, okay. So, like you will be given a joint distribution of that x and y. Okay. Then we will calculate the covariance and we will see if we are getting the negative value, positive value, or what value we are getting. If we are getting the positive value, that means the values of x is increasing, then the value of y is also increasing. If we are getting negative value, that means if x value is increasing, y is getting decreased. Just by calculating the covariance, then only we can get the relationship of the x and y.
Okay, can this be possible? Like if the covariance is positive, x can be decreasing and y can be decreasing as well, or it's just increasing only?
I'm sorry, what?
The first case, ma'am, when covariance is positive, can x and y both decreasing as well?
That will be positive correlation. No?
Yes, yes. Both are moving in the same direction is covariance is positive.
Okay.
If they both move opposite direction, it is negative. If the movement is insignificant, that is closer to 0, then they are not correlated.
Okay. Okay. Thank you.
Ma'am.
Yeah.
Doesn't you explain this positive, negative, and 0 in the context of correlation? Because what I have understood that covariance simply means that what's the direction of x and y, whether x and y is moving in same direction, x and y is moving in opposite direction, and x and y is not moving in any similar direction. And correlation means that the variable x and variable variable y are positively correlated, means that they are moving in same direction. Negatively correlated means they are moving in opposite direction. When correlation is zero, then there is no relation between the movement of the either of the variables.
See, in correlation, we calculate the strength. The correlation values are between -1 and 1, right?
Yeah,
so if we are having negative, the values is like
0.5.
minus 0.5 or something like that. So from that we get the strength of the relationship between them.
How strong x and y are correlated.
Yeah, in this we are only getting the direction. But in that we are getting the strength and the direction, both part. Fine?
Okay.
Yeah. Yeah. Let's take an example of how to calculate a covariance. Okay. So if I'm having a joint distribution table as this is x and this is y, x is taking value -1, 0, and 1, and y is taking values as -1, 0, and 1. The probabilities are 1 by 15. 1 by 15. 10. So how will you calculate the covariance of x and y? It will be equal to expectation of x minus expectation of x and y minus expectation of y. So first of all, here we have to calculate the expectation of x and expectation of y. Correct? So how we will calculate the expectation of x? Any idea?
Find the possible values x can take.
C. Yeah, correct.
I'm using marginal.
Marginal, yeah. So if x.
Just a minute. Your probability doesn't add up to 1. You may have to tweak those figures. Your joint probability distribution doesn't add up to 1. 5.
It's coming out to be 1. No?
Oh, sorry. Sorry. Sorry, my mistake.
Yeah, it's fine. Yeah. So we were calculating. The expectation of x. So first of all, we will find out the marginal distribution. Okay. So for -1, the marginal distribution is 5 by 50. That is 1 by 3. Similarly, for 0, it will be 1 by 3. For 1, it is 1 by 3. Okay. So the expectation is -1 into the probability for the function plus 0 into 1 by 3 plus 1 into 1 by 3. Correct? Is this clear?
Yes, ma'am.
So it will be 0. Similarly, we will calculate the values of y. So what is the marginal distribution of fy?
1 by 3.
For -1, it is
1 by 3 for all again.
Yeah, 1 by 3 for all, and fy will be 0. So these value is 0. So at last we will get the covariance of x comma y as expectation of x and y, right? So expectation of xy will be That is for -1 into -1, the probability is 1/15. Okay. Similarly, -1 into 0, the probability is
2/15.
Similarly, -1 into 1, it is 2/15. So we will calculate all other values. Right? So if we calculate these values, we will get as -2/15. Okay, here we are getting the negative value. The covariance is negative. Right? So it is like we can conclude that if x is increasing, then y is decreasing, or if y is increasing, then x is decreasing. That's it. They are going in opposite direction. Fine. This is how we calculate the covariance. Is the calculation part clear?
And since we have the same values that x and y can take, and they also have the same probability, I'm finding it hard to imagine how they move in the opposite direction. What does movement even mean in this situation?
Like it's like movement in the sense if the values of x is increasing, the values of y is decreasing, like sort of like that. It's just an example, that's it. So if
I mean, it should be -1/15, right? Not -2.
it's coming out to be 2/15, -1/15.
I think EXY calculation,
Yes.
we have only 4 combinations to calculate. I think we can calculate.
Yeah.
Right?
Yeah,
We can strike down the middle row and middle column. Just 4
Yeah,
columns,
we
four
can.
elements left. That seems to be
So
something.
between -1 into 1/15 plus between -1 into 1 over
Right, almost to 0 now. They are not related.
sorry, what? So this will be cancelled. So 2/15 -2. We're getting positive value, not negative. Is this clear? No. Sorry. The calculation is wrong.
Yeah, the value seems to be 0.
Plus, so this will get cancelled. We will get -2. So we are getting -2/15.
Yes, ma'am. -2/15.
Yeah. So it's just that it's just showing that if the values of x is increasing, then the values of y decreasing, or vice versa. That's it. Like they are going in opposite direction. That's it. Is it clear how to calculate the covariance?
Yes, ma'am.
Anybody having any doubt? Can I proceed further? The calculation part is clear?
Yes, please.
So there are some properties of covariance as well. So if I have to calculate the covariance of x comma x, right? So it will be variance of x, right? If I have to calculate the covariance of the same variable, then it is equal to the variance of that variable. Okay. And secondly, covariance of x comma y can also be calculated as expectation of xy minus expectation of x into expectation of y. Okay. Thirdly, covariance of x comma ay plus bz is calculated as covariance of a into covariance of x comma y plus b into covariance of x comma z. Okay, and if we have covariance of ax plus by comma z, then it will be calculated as a covariance of x comma z plus b covariance of y comma z. Are these properties clear?
Yes, ma'am.
Yeah. Okay. Now, if x and y are independent, okay, they are independent, then covariance of x and y are 0. Fine. That means they are uncorrelated. So if two random variables are independent, that means that they are uncorrelated. Okay. But the reverse is not. That is, if it is given that they are uncorrelated, that doesn't mean they are independent. They can be dependent also. Fine. Is it clear?
Yes, yes, ma'am.
And can that really be the case? If x and y are not affecting each other, isn't that enough to say that they're independent?
No, there are cases. It is not necessary. Like, for example, we can take an example. X and y, they are taking values. -1, 0, 1, and y is taking value 0 and 1. Okay. So the probabilities are 1/8, 1/4, 1/0, and 1/4. So first of all, we can, if we like, it is given that the covariance is 0. Okay, if we calculate the covariance of x as, we will get at it as 0. Okay, that means it is uncorrelated. Okay, now if we have to find out that like the dependency. Okay, so it will be we know that if x and y are independent, the expectation of x comma x into y is expectation of x and expectation of y.
Yes.
Yes.
No, sorry. We are calculating the independence of these variables, right? So if we have to calculate the independence, we will take the values of x, y as function of x and function of y, right? So if I have to calculate, like for x is taking value -1 and y is taking value 1, right? So for this, the value is 1/4, correct? If x is taking value -1 and x is value -1 and y is taking 1, the probability is 1/4, right? But if I calculate for x is equals to -1, it is marginal distribution. It will be 3/8, right? And for y is equals to 1, the marginal distribution is
2/4.
Yeah, like
Or 4/8.
So it will be 1 by 2. So if we multiply these values, we will get 3 by 8 into 1 by 2, which will be equal to 3 by 16, right? So here the values, the joint distribution of fx, and if we multiply each, they are not equal, right?
Yes, got it.
So that means they are not independent, they are dependent.
Yes, yes.
Yeah, so that's the case. It is like we have been given the covariance is 0. That means they're uncorrelated. But if we find out the dependency, they are not dependent.
Okay.
Sorry, they are dependent. They are not independent.
Yes, ma'am.
So always remember the reverse case is not always true. If it is given that they're independent, then that means they're uncorrelated. That's for sure. But the reverse is not compulsory. If it is given uncorrelated, that doesn't mean that they are dependent, that they're independent. They can be dependent.
Yes, ma'am. Got it.
Got it?
Yeah.
So, ma'am, we can say like this also, that if x and y random variables are dependent, then covariance between these x and y may or may not be equal to 0.
Like if they are dependent, then covariance is?
Covariance of that random variable x and y may or may not be equal to 0.
It will not be equal to 0. See.
If they are dependent.
See,
okay.
The covariance is calculated as expectation of xy minus expectation of x into expectation of y, right? And we know that if two random variables are independent, then expectation of xy is equal to expectation of y, correct? If they are independent.
Yes, ma'am.
Means these two values are equal. They will get cancelled. It will be equal to 0.
Yes.
And you're saying that they are dependent. If they are dependent, then this condition will not be satisfied.
Yes.
If this condition is not satisfied, we will not get the covariance as 0.
So it will, in case of dependence between two random variables, their covariance should never be equal to 0.
Yeah, because these two values are not getting equal.
Yes. Okay.
Yeah.
Wait, but then how did you get the above example?
No, I think
it is for independence case. I am considering dependent.
To calculate the covariance of this, we can calculate. If you want, should I calculate?
No. I'm not asking you to calculate. I'm just asking what was the assumption here, that we first assumed.
No, here I'm taking the example. If we calculate the covariance of this, we are getting covariance as 0. I have calculated it. After calculating, I'm getting covariance as 0. Okay. And if I calculate the dependency or the independency of these two variables, it is getting dependent, right? Because fx is not equal to fx into fy, right?
Okay. So if the covariance is 0, it does not directly imply that they will be always independent.
Independent, yeah, correct. Okay, it just says that if x and y are independent, then it is always true that the covariance is 0. That is, they're uncorrelated. But the reverse is not true. Like, it is not necessary that if we have been given, right? If we have been given that covariance is 0, that doesn't mean that these two variables will always be independent. They can be dependent. So it is not always true for the inverse case. For this case, it is always true that it is given x and independent, that is covariance is 0. Like, without any thought, if it is given independent, that means the covariance is 0. But the reverse is not true. Fine?
Then, if covariance is not equal, is equal to 0, if this doesn't mean that x and y are independent, it may be dependent. So it is dependent. So when we say that if x and y is dependent, then covariance should never be equal to 0. We concluded that earlier, no?
Yeah.
But in this case,
1 minute. Independence decides whether the covariant can be 0 or not the other way around. Covariance does not give anything about independence.
Dependence or independence?
Yes. Yeah. There can be a situation where they are dependent and still the covariance is 0.
Yeah.
That can be a sample. That maybe the sample is such we get a covariance 0.
But they are dependent.
Independent. The independence is the structure itself, the experiment or whatever that is the experiment itself. Whatever we are doing, a covariance is an inference from the data that we observe.
So suppose if covariance is equal to 0, this doesn't imply that the variables, the random variables which we are studying, they are dependent or independent.
Correct.
So this means that if covariance is equal to 0, then our random variables, the samples which we have taken for that particular random variable, can be dependent, can be independent.
Yes, it doesn't talk anything about independence or dependence.
We cannot conclude by simply seeing or calculating the covariance is equal to 0.
You are absolutely right. Covariance does not give any information about the independence
or dependence.
Whereas once you know the dependent or independent, if it is independent, we know very clearly covariance has to be 0.
Will be 0.
You need not calculate waste.
So sir, I am thinking in the reverse.
No, reverse. That's what she keeps saying.
No. I am reverse in that sense. Not. If we know that x and y are dependent, then in that case covariance will not be equal to 0.
Not necessary.
That I am trying to understand.
It can be. It can be anything.
It can be 0 or it cannot be 0.
Correct.
Yeah, that I am trying to understand.
Okay. Is it clear now?
Yes, ma'am.
The covariance part is clear?
Yes.
Okay. Now comes the correlation part. So what is correlation? In covariance, we got the direction, but in correlation, we get the strength of the two random variables, right? So what is the strength between the two random variables? How positively correlated are both of the random variables, or how negatively correlated both are? Okay. So the formula it is denoted by rho of x and y, and the formula is covariance of x comma y divided by the standard deviation of x multiplied by the standard deviation of y. Okay. And the values, the range is, the correlation ranges from -1 to 1. Okay. So if the correlation is -1, that is, it is strongly negative. If it is 1, that means it is strongly positive. And if it is 0, that means it is uncorrelated. Is it clear?
Yeah, less than or equal to, right?
Yeah, less than. Okay. Less than? Yeah, less than. No, it's, yeah, it's less than equal to. If it's -1, then it's strongly negative. If it's 1, it's strongly positive.
Clear, ma'am.
Yeah. So if we this way we calculate the correlation. If we want to find out the correlation through a graph, okay. So like if I draw, this is the y value and these are the x value. Okay. So if I draw manually like this, so these data points are like the value 1, and this is taking 3. So this point is 1, 3. Similarly, all the data points are like that. So here if we see that it is not showing any trend, right? It is not it is not showing if it is increasing or decreasing or anything, right? So it is just like it is uncorrelated. Like if the values of x is increasing, there is like we cannot say the values of y is also increasing. Some of it is like x is increasing, the y is decreasing, and some is like x is increasing, x is increasing, y is also increasing. So we cannot say about the relationship between the x and y, right? So the correlation is 0 here. Is it clear?
Yes, ma'am.
Yeah. And if I'm having another graph like this,
Positively.
okay. So this is positively correlated, right? That means if x is increasing, the y is also increasing, correct?
Yes.
And if I have this type of graph,
-1.
It's negative. That is, if x is increasing, the y is getting decrease. So from the graph, you can conclude if what is the relation between the correlation between the x and y. If it is strongly positive, strongly negative, or like that. See, this is close to 1 because it is linear, right? So this will be close to +1. That is this. And this is also linear, right? So this is also close to -1. So it is strongly positive and this is strongly negative. If I'm having a graph like this, let's say, like it's not a bit linear, but it's like it's showing that it's the values of x is increasing and the values of y is increasing. Like it's not linear, right? That means it is not, it is close to like we can say
0.5.
Yeah, means it is not that it is not 1, but near to 1. That's it. Between 0 and 1. That it is positive correlated. That's it. Similarly, we can have the graph like this in negative direction. Then it will be between -1 to 0. Fine.
And if it's a straight line upward or downward, then it will be perfectly positive or perfectly negative.
Yeah, like it's linear. If it's linear like this.
Yeah.
Fine.
So the width of the scatter of the points, xy coordinates, that defines that how much strong it is, whether it on the negative side or on the positive side.
Yeah.
You can conclude like that.
Yeah.
If the depth of the scatter is very minimal, then it is very close towards 1. If it is wide, quite wide, then we can conclude that it may range between anywhere between 0 and 1.
Is this plot clear? Correlation is clear?
Yes, ma'am.
Now the last topic is Markov's inequality and Chebyshev's inequality. Okay. So what is Markov's inequality? Markov's inequality states that if x is any random variable, okay, taking non-negative values. Okay, x is only taking non-negative values. Just remember that with finite mu. Here mu is the mean of that random variable. Okay, we denote mean as mu. Fine. So if x is a non-negative value, non-negative random variable, and with a finite mean that is mu, then probability of x greater than equal to c is always less than mu by c. This is the Markov's inequality. In like this will provide the upper bound, right? So this is the greater than sign. So it will provide the upper bound that a like that this value is greater than equal to some positive value. Fine.
Ma'am, can you please repeat once again this Px is greater than or equal to C?
See, the Markov inequality is just that it tells us we can say that like how this x random variable is far or larger than the mean value. That's okay. So if x is a random variable taking only negative values with a finite mean, then the probability of x greater than c is always less than equal to mu upon c, where mu is the mean. You have to just remember this function.
Isn't it that, ma'am, it will always be this case? If we take, suppose x and suppose any value, x is non-negative and c is also some non-negative, and x is greater than or equal to c, then it will be always be less than this ratio, mu by c.
Yeah, it will be less than.
It will always be this particular.
Yeah, this is one expression of Markov's inequality. If we have to find out the upper bound, that what is the upper bound? That the variable is greater than some positive value. What is that upper bound? Like for example, like let's take a situation. If the average number of minutes a person is waiting for a bus, okay, it is 10. Like for the expectation that he is waiting for a bus is 10. Fine. If we have to find out the person wait more than 30 minutes. Okay. So what is the upper bound? Right. So we will calculate probability of x greater than equal to 30. It will be less than mu, that is 10 divided by c was 30, will be this. Right. So we are calculating here the probability that a person has to wait more than 30 minutes, right? So it will be less than equal to 1 by 3.
What does this upper bound and lower bound means?
Sorry, what?
Upper bound and lower bound, what does this mean?
Like this is an upper bound. That means the probability that he has to wait more than 30, it is less, the probability will be less than 1 by 3. That's the upper bound. After the maximum point, you can say.
It means that if we have to wait for more than 30 minutes,
yeah,
then its probability will always be equal to 1 by 3.
Yeah, less than equal to 1 by 3.
Less than or equal to 1 by 3.
Fine. That's the meaning. So Markov's inequality is calculated when we have the mean. Okay, if we have given a random variable which is non-negative and the mean is given for that random variable, and if we have to find out the upper bound, then we calculate the Markov's inequality. Fine?
Yes.
Is the Markov's inequality clear for everyone?
This is the probability he has to wait for more than 30 minutes. Okay.
Like if they are asking the probability, how much for the probability of how much time, for example, what was that person has to wait for more than 30 minutes. So what is the probability of his waiting? We have to calculate. So we just calculated the upper bound. Like maybe it will be 1 by 3 or less than 1 by 3. That's it.
It is not the time, right? It's a probability he has to wait.
Yeah, it's the probability he has to wait.
So simply if we consider this example and we have calculated for 30. If we are calculating for 40, it will be less than 1 by 3.
Less than 1 by 4.
Less than 1 by 4, and 1 by 4 will be less than 1 by 3. Suppose we are calculating that if we have to wait for 20 minutes, 30 minutes, and 40 minutes, then the lowest probability will be which one?
you're calculating for all the 30,
different situations. I am considering different situations. That the expected value of his wait is 10, suppose 10 minutes. Then what is the probability that he is going to wait for 20 minutes, 30 minutes, 40, more than 20 minutes, more than 30 minutes, more than 40 minutes, more than 50 minutes? Suppose these are the 4 or 5 situations. Then I am trying to conclude a thing that which probability will be the least one. That it will not go come below that particular probability. Because here we are saying that it should not be less than or equal to 1 by 3.
Sure. It is, the probability is less than equal to 1 by 3. We are just calculating the upper bound. That's it.
So it simply means that if the wait time is more than 30, then that probability will in any case be less than 1 by 3. Because this is the upper bound, up to 30 minutes.
Up to 30.
Yeah. If we have to wait for 40 minutes, which is greater than 30 minutes, then when we calculate the probability, even without calculating the probability, we can safely say that its probability will be not more than 1 by 30, 1 by 3. Yeah.
Now is it clear? The Markov's inequality?
Yes.
Everyone?
Where do we have to use this? Will we have problems based on this?
Yeah, if you have been given the values of x, which is non-negative, and the value only mean is given, then we can calculate the upper bound. Okay. Now the second comes the Chebyshev's inequality. Okay, so what is Chebyshev's inequality? It is given as, like, if x is any random variable, okay, it is not necessary it should be negative or non-negative. Okay, if x is a random variable and the variable's mean is given, that is mu is given, mean, and the variance is given, that is sigma square. This is the variance of x. Okay, sigma square denotes the variance and sigma denotes the standard deviation. Okay, so if a random variable x is given, it is a discrete random variable, and its mean and variance is given. So the Chebyshev's inequality is denoted as probability of mod of x minus mu is greater than k sigma is always less than 1 upon k sigma. This is the expression of Chebyshev's inequality. Here we have been given the variance and the mean. In Markov's inequality, only mean was given. But in Chebyshev's inequality, mean and variance, both of the values are given. And k is some constant value. Okay. So, like Chebyshev's inequality, it also gives the bound, right? It also gives us the bound that it states that the value of that random variable, okay, the value of that random variable deviates from its mean, okay, by more than a certain amount, right? Is it clear? What does it state? It states that the value of that random variable deviates from its mean by a certain amount based on its variance, right? With some with some units.
Madam, here this sigma, it will, if it is variance, then it should be square, no?
Sorry, what?
You have written k into sigma, so it is, and sigma is a standard deviation. It will be sigma square, no?
No, in this
it could be variance.
We are taking the sigma, that is standard deviation.
So okay, k times the standard deviation.
Yeah, k times the standard
deviation. Okay.
Okay. So for example, like let's take an example. So the average score in an exam was like 70. Okay, the expectation is 70, and we have been given the variance as 100. Okay. So if we have to calculate the probability that a random, randomly selected score deviates from the mean, okay, if x is a variable, right? So x is getting deviated from the mean. Okay, it is getting deviated from the mean by more than 20 points. Okay. So we have to calculate the probability. This probability we have to calculate, right? So if we just compare this equation and this equation, right? So here 20 is equal to
1/5.
K sigma. It is equal to K sigma, right? You getting my point?
Yes, ma'am.
K equal to 2.
Yeah. So here, if we have to calculate the value of K will be equal to 20 upon sigma, right? And here the value of sigma is
10,
which will be equal K is equal to 2. So probability of x minus q greater than 20 will be less than equal to 1 upon k square, and value of k is 1 by 2 square, that is 1 by 4. Right? And the 1 by 4 is equal to 0.25 something, right? So that means that at most 25% of the students scored more than 20 points from the mean. You getting my point?
Yes.
Everyone? Any confusion? Hello, is it clear?
Yes.
Sure, everyone. Chebyshev inequality is clear for everyone.
Yes, ma'am.
Yes, ma'am.
Okay. So, when do we calculate the Markov's inequality?
And we have only the mean expected value.
Okay. And what expected? What is the condition? Like, one more condition was there.
Greater than a constant.
Non-negative values.
Non-negative values. And when do we calculate the Chebyshev inequality?
For all.
Like, yeah, for all, when we have been given the value and standard deviation or the variance.
Oh, so in the case of okay, so in the case of Chebyshev's, it need not be positive values alone.
Yeah, it should be a discrete random variance.
Okay.
See, in this, there is another form of Chebyshev's inequality. In this, we got our upper bound. Okay, so if we have to calculate the lower bound, we can calculate it as probability of minus k sigma less than x plus 5 plus k sigma. This greater than this will give us the lower bound as well. So if in the question it has been asked about the upper bound, then we will apply this formula. If it has been asked about the lower bound, we will apply this. Is it clear?
Yes, ma'am.
Fine by everyone? No doubt?
Why do you call this as a lower bound? What does it signify? It's
because
just a complement of the other one.
Yeah, but just see, no, like this probability is greater than this value.
No, if the probability of it falling within that range, beyond the range is 1 by k square, falling within this one, anyway, complement of it. Why do we use the term lower bound?
Like if it's in the question, it has been asked about the lower bound. Like what will you look like? What equation would you look like? Like there are some questions.
Questions are framed like this, but the term lower bound gives me a misleading concept. You know, you have something to call an upper bound. The lower bound of a probability is what?
Yeah, the left hand side should be the same, exact same, and then
it's no different. No, it's two formulas, one and the same.
Yes, yes.
Yeah, it's same only. But if it has been asked about the like we can say.
I'm trying to understand the terminology used in this course. Upper bound makes sense, okay. But when we say lower bound, something which is varying, we are fixing an upper bound. Understandable. If you are fixing a lower bound for a probability is 0. Why are we using the word lower?
It's not necessary that always the lower bound is 0. Like it can be like the probability can be greater than equal to you can say 1 by 3, or it can be greater than 2 by 5, something like that. Like the probability starts from this value. It's not necessary that all the lower bound starts from 0 only. You getting my point? Hello?
I'm thinking. I'm able to figure out why we use the terminology. Because I see no difference between the two formulas.
Yeah, there is no difference. In this, we are just calculating the complement of.
Yeah. So it's a complement.
This is just a complement. Okay. There is like if it's the question is given that what is the probability that it takes a value between just say 30 or 50, something like that. Then we calculate this value. What is the lower bound that the x takes values between 30 and 50?
That's then okay. That's all right. But why are we using the word lower bound? That's what the upper bound makes meaningful. Yes, it cannot be more than that. Yeah. That is why we call it as an upper bound. At least it conveys a meaning or a concept. Under what conditions we say that we are guaranteeing it that it is not going to be less than this. You get my point?
Like we are just stating that it starts like the probability is
what we are saying is the probability of falling within this range given is greater than this. That's why we probably say that. If you're saying probability of getting 90% is 25%, the probability of its mark falling within 70 and 50, sorry, 100 and 90 and 50 is greater than 2/3, something like that. Yeah. Is that the reason we say it is a lower bound?
Yeah.
Okay. Half empty, half full.
Like in the doubt session, I can clear this out. Study more about it. Yeah. You're just the question. Your question is like why we are saying the lower bound, right?
Yeah. The term. I mean, I'm just concerned about the terms we use, which are unnecessarily likely to cause confusion. So that's okay. Earlier we said what is the probability it will fall beyond the range, within the range. Now you are saying it is outside the range, is it?
outside? Which one? This one. This is within the range, right? The variable, the x variable is taking between the two values. So what is the probability that the x is
Correct.
taking?
But the earlier one is within the beyond the range.
Beyond that range, yeah.
That's why I'm saying it's one and the same. So whether the glass is half empty or half fill, it's two different way of looking at the same thing, but the figure is same.
Yeah.
1 by k square.
1 minus 1 by k square. I'll get back to you. Right?
No, that's okay. It's not a consequence, I mean, important thing to discuss about. Anything else you want to discuss today?
No, it's fine. Yeah, this was the last.
Thank you. Thank you. Thank you very much.
Yeah. Yeah. So anybody having any other doubts?
No, ma'am.
On today?
Ma'am,
Yeah.
can you explain activity 2?
I will explain it on Tuesday. Yeah, Yanni, it's your turn.
Yeah, it's not related directly to the material we discussed. Ma'am, we have the Solve With Us solutions on, Solve With Us sessions on Tuesdays, right?
Yeah.
So I won't be able to attend it live, but if you have any questions, can we post it on the Discord channel, not Discord channel, the discussion forum related to the Solve With Us session?
Yeah, but like on Tuesday only you can ask about the solve this questions. Any doubt you can ask.
Yeah, I was trying to say that I won't be able to make it live on the live sessions. So if we have any doubts, can we post it on the forum?
Yeah, you can.
Okay.
Okay, so can we end the meeting now? Nobody is having any doubts.
Yes, ma'am. Thank you so much.